Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry, Lesson 2-4, Reasoning in Algebra. So these are some of the properties of equality that you have already gone over in various other classes, but just so we can quickly remind you of them, if you add something to both sides of the equation, it's called the addition property. If you subtract something from both sides of the equation, it's the subtraction property. If you divide something on both sides of the equation, it's the division property. And if you multiply something on both sides of the equation, it's called the multiplication property. Substitution property says that if A equals B, then B can replace A in any expression. And then the distributive property starts with A times the quantity B plus C. And you actually multiply A by everything inside the parentheses. So A times B plus A times C. And then the only other thing I wanted to remind you guys is that when you are going to simplify, you will always simplify on the same side of the equal sign. So if you need to do x plus 3 plus 2x equals 8, and you combine your x's and your 2x's together, because they're on the same side of the equal sign, you would get 3x plus 3 equals 8, and that would just be simplifying your equation. So just a little hint for your lesson and your practice. All right, so here are some new properties of congruence that we need to go over, and that first one is the reflexive property of congruence. So reflection, like a mirror image, so if you have segment AB, and we're going to do the reflexive property of congruence for that, you will still have segment AB. You may also have an angle. So for example, you might have angle A, and the reflexive property says that angle A is congruent to angle A. And so anytime you have one thing equal to basically itself or congruent to itself, that is using the reflexive property of congruence. Our second one is the symmetric property. And the symmetric property of congruence is actually going to flip these around. So if we have AB, segment AB is congruent to segment CD, our symmetric property is going to switch these places. So it's going to end up with CD is congruent to AB. And so it just flips them around. If you have an angle, the same thing happens. So you might have, angle A is congruent to angle B. That was an ugly angle. And then it flips it around with symmetric property, and you have angle B is now congruent to angle A. And so that's the symmetric property when they switch places, symmetric switches. And then our last one is the transitive property. And this one's definitely the longest version of that, so I'm going to type it out rather than draw it. All right, so what it says is that if AB is congruent to CD, so those two are the same, and that CD is congruent to EF, those two are the same. What it says is that once again, you can kind of cut out the middleman and the CDs there, and you can say that AB is congruent to EF. And the same holds true for angles, of course. If you have angle A congruent to angle B congruent to angle C, you can cut out the middlemen here of B's and say that angle A is congruent to angle C. And that's the transitive property. All right, let's do some of your homework. This one comes from the lesson. It says line XY is congruent to line XY. So notice that these are the same things. So this would be reflexive because it's the same on both sides. All right, here's another one for us. If the measure of angle A equals 45, and 45 equals the measure of angle B, then angle A equals angle B by what property? So again, we can cut out the middleman here and say that A equals B, and whenever you're cutting out the middleman, it is a transitive property. All right, this one is from your practice. If line ST is congruent to line QR, then line QR is congruent to line ST. And it starts with ST and ends with QR on this side, and then they switch. So whenever they switch, it's always the symmetric property. So switching is symmetric. All right, and then we're going to do the last one from the practice here. And it says that in the figure above, km equals 35, and they want us to solve for x and match the justification for each step. So our step 1 here says that KL plus LM equals KM, and that is the segment addition postulate. Segment addition. That's what it is. The small piece here plus the slightly bigger piece will equal the whole thing. So that's segment addition postulate. Step 2, instead of KL, they wrote 2x minus 5. Instead of LM, they wrote 2x. And instead of KM, they wrote 35. And that is substitution. So step 2 is the substitution property. For step 3, they took the 2x's here and put them together to make 4x. But since those are both on the same side of the equal sign, that's called simplifying. And then for step 4, it looks like they moved this 5 to the other side. In order to move a subtraction, you have to add. And then to get to step 5, it looks like they divided both sides by 4. So the last one is division. They divided, the division property of equality. And then to find the length of KL, which is the last part that they ask you for, you take the x equals 10 and you plug it in up here on KL. So 2 times 10 minus 5. So 20 minus 5, the answer is 15. Good luck, everybody. I hope you guys all do great.